Hi everyone, we are students from Bachelor of Mechanical Engineering, FTKM UTeM. Today we are going to discuss about ozone layer, refrigeration production, and phase out. This is our team, Amir Imran, Amiru Asmawi, Arisha Shamila, Ashley, and me, Chong.
Before discussing ozone depletion and refrigerant phase out, let's first understand what is a refrigerant. A refrigerant is a working fluid used in refrigeration, air conditioning, and heat pump system. Its main function is to transfer heat from one place to another through a continuous refrigeration cycle. In the evaporator, the refrigerant absorbs heat from a low temperature area such as inside of a refrigerator or an air conditioned room. It then releases this heat to the surrounding through the condenser. Refrigerants are commonly used in household refrigerator, air conditioner, freezer, and industrial cooling system. An ideal refrigerant should have high cooling efficiency, be chemically stable, non-toxic, non-flammable, and most importantly, environmentally friendly. Alright, now let's look at the ozone layer and why it is important. The ozone layer is a region in the stratosphere located approximately 15 to 35 kilometers above the Earth's surface. It contains a high concentration of ozone molecules, which are made up of three oxygen atoms. The ozone layer acts as a protective shield by absorbing most of the harmful ultraviolet or UV and the radiation from the sun. This protection is extremely important because excessive UV radiation can cause skin cancer, eye cataracts, and damage to plant, animal, and marine ecosystem. Without the ozone layer, life on Earth would be exposed to dangerous level of UV radiation. Therefore, protecting the ozone layer is essential for maintaining both human health and environmental balance. In the next section, we will discuss how certain substances, including some refrigerant, contribute to ozone layer depletion.
Next is the ozone layer depletion. The causes of ozone layer depletions are from human activities such as the release of CFCs. CFCs are released from older generation refrigerators, air conditioning, and aerosol cans. So since CFCs are inert, they do not dissolve in water and they persist in the atmosphere. Next, they slowly diffuse into the stratosphere and they are exposed to a short wavelength of UV radiation. Thus, it is causing a destructive chemical reaction. Next is the common ozone depleting substance or DS. First is chlorofluorocarbons, CFCs, hydrochlorofluorocarbons, HCFCs, hydrofluorocarbons, HFCs, halons, and methyl bromide, CH3Br. The effects of ozone layer depletions are skin cancers, sunburn for short term, wrinkles, dark patches for long term, risk of cataracts, harms marine phytoplankton, and disrupts marine food chain. Next is the ozone depletion mechanism. So the chemical process are the CFC molecules drift into the stratosphere and it is struck by a short wavelength of UV radiation. The UV energy splits the CFC molecule and a highly reactive chlorine atom break away. Next, the chlorine atom collides with the ozone molecule. Then it steals oxygen atoms to form chlorine monoxide, ClO, and leaving behind oxygen molecule. So the reactions are chlorine release, the CCl3F plus UV radiation, it turns into CCl2F plus Cl. So the ozone destruction is Cl plus O3 turns into ClO plus O2. The net reaction is ClO plus O equal O2 plus Cl. So the key points here are chlorine atom is continually regenerated and it is free to attack and destroy ozone, and a single CFC molecule can destroy up to 100,000 ozone molecules. Next is the refrigeration production. There are four production methods such as synthetic fluorination, natural refrigerants, refrigeration blends, and recovery and recycling or reclamation. For the first production method, the process it reacts chlorinated hydrocarbons with hydrogen fluoride using catalysts, replacing chlorine atoms with fluorine to achieve desired molecular design. The refrigerant category are CFCs, HCFCs, and HFCs. The common examples of refrigerant are R11, R12, and R115. Next production method is the natural refrigerants. The process are it captured and refined from existing environmental or industrial sources. The refrigerant categories are hydrocarbons, HCs, carbon dioxide, CO2, and ammonia, NH3. The common examples are R290, R600A, R744, and R717. Next production method is the refrigeration blends. The process physically mixing two or more distinct chemical compounds. The refrigerant categories are zeotropes 400 series and azeotropes 500 series. The common examples are R4110A and R407C. And lastly, the production method for recovery and recycling. So it basically uses refrigerants extracted from decommissioned equipments and filtered to remove impurities. So the category of these refrigerants are HCFCs, and the common examples are R22.
Good day everyone, I'm Chong. I will be presenting on the evolution of refrigerants and environmental indicators. The evolution of refrigerants was driven by the need for safer, more efficient, and environmentally friendly cooling technologies. In the early 20th century, Thomas Midgley Jr. and his colleagues searched for the ideal refrigerants by studying the periodic table. Many elements were excluded from the consideration, such as metal were rejected because they form non-volatile compounds, while the noble gases had extremely low boiling points. Also, toxic and unstable compounds were eliminated. This left only eight important elements: carbon, nitrogen, oxygen, sulfur, hydrogen, fluorine, chlorine, and bromine. The researchers observed that flammability and toxicity generally decrease from the left to right and from the bottom to top in the periodic table. This led them to investigate chlorinated and fluorinated hydrocarbons, where varying the amount of chlorine and fluorine affected boiling point, flammability, and toxicity. The first generation of refrigerants from 1830 to 1930 focused primarily on substances that simply work and were available. Natural refrigerants such as ammonia and carbon dioxide were commonly used. Although environmentally friendly, but some of the natural refrigerants are toxic, flammable, or operated at a high pressure. The second generation from 1930 to 1990 introduced chlorofluorocarbon or CFC such as R11 and R12 and later hydrochlorofluorocarbons HCFC such as R22. These refrigerants were safe, stable, efficient, and non-flammable. However, because they contained the chlorine, they contributed to ozone depletion and had high global warming potential (GWP). As a result, they were eventually phased out under the Montreal Protocol. The third generation from 1990 to 2010 focused on ozone protection. Hydrofluorocarbon or HFC such as R134A were developed without chlorine, giving them zero ozone depletion potential (ODP). However, they still possess relative high GWP and are now being phased down in many countries. The fourth generation, from 2010 to the present, includes hydrofluoroolefin or HFO. These refrigerants have zero ODP and very low GWP because they break down quickly in the atmosphere. However, many HFO are mildly flammable, creating a trade-off between environmental performance and safety. Overall, the refrigerant industry has evolved from prioritizing performance and safety to balancing efficiency, ozone protection, and climate sustainability. Next, environmental indicators. There are two important environmental indicators, which are ozone depletion potential, ODP, and global warming potential, GWP. ODP measures the ability of a refrigerant to damage the ozone layer, while GWP measures the ability to trap heat in the atmosphere compared to carbon dioxide. From the graph, we can see that R11 has the highest ODP of 1 and very high GWP of around 4700. R22 has a lower ODP of about 0.05, but its GWP is still approximately 1800. R134A has zero ODP, although its GWP remains relatively high at about 1400. In comparison, R1234YF has zero ODP and a very low GWP of 4, while carbon dioxide also has zero ODP and a GWP of 1. Therefore, R1234YF and carbon dioxide are considered more environmentally sustainable alternatives.
So next is about the refrigerant phase out. So what is the refrigerant phase out? The refrigerant phase out is a process of reducing or completely getting rid of harmful refrigerant that cause depletion of the ozone layer or cause global warming. So the main objective of phase out is to protect the ozone layer from depletion, reduce emission of greenhouse gases, and encourage of the use of eco-friendly refrigerant, and lastly contribute to the global sustainability efforts. So next is about the Montreal Protocol. What is the Montreal Protocol? Montreal Protocol is an international treaty signed in 1987 to save the ozone layer by phasing out the ozone-depleting substances like CFCs and HFCs. Montreal Protocol sets a schedule for countries to phase down their usage of dangerous refrigerants to opt for better and greener alternatives. So the key achievement of the Montreal Protocol is reduction of more than 99% of ozone-depleting. Second, healing of the ozone layer and protection of the UV radiation rays. So why the Montreal Protocol is successful? So first is participation of the all the UN member countries and strict timetable of phase-out procedures and international cooperation and financial aid.
Okay, so let's talk about the Kigali Amendment. Basically, back in 2016, the world came together to update the Montreal Protocol. For a long time, the industry was using chemicals called HFC to keep our fridge and air conditioners cool. Now, the good news was that HFC didn't damage the ozone layer, but the bad news, they turned out to be superpower greenhouse gases. Some of uh, some are thousands of times more potent than carbon dioxide when it comes to trapping heat. The Kigali Amendment is our global game plan to fix this. The main goal is to drastically phase down the production and use of HFC by about 80 to 85% by the year 2047. Why should we care? Because the expected benefits are massive. By making this one shift, we are projected to prevent up to zero point 0.5 degrees Celsius of global warming by the end of the century. It is truly one of the biggest, most impactful things we can do to fight climate change right now. So, if we are getting rid of HFC, what are we using instead? On this slide, we look at the environmentally friendly alternative. We generally group this into two sides. First, we have HFO, like R1234YF and R12340ZE. These are newer synthetic options designed specifically to have zero impact on the ozone layer and a wonderfully low global warming potential. Second, we have the natural refrigerants. These are exactly what they sound like, substances found in nature. We got ammonia, which is super energy efficient and great for heavy industrial use. So there is carbon dioxide, which is entirely natural and is becoming the go-to for modern supermarket cooling. And finally, we have hydrocarbons like propane and isobutane. To give you an idea how much better these are, propane has a GWP of just 3 compared to all the chemicals that were in thousands. Studies show that switching to a propane blend can cut a cooling unit's total environmentally warming impact by up to 96%. The overall advantage here is clear. We get excellent sustainable cooling with a tiny fraction of the environmental footprint. So this slide will breaks down the challenges we are currently facing. The biggest technical challenge is that a lot of these eco-friendly refrigerants, especially propane, are flammable. Because of that, we can't just pour them into our old AC units. We have to redesign the equipment, add strict safety measures, and train our technicians so everyone stays safe. Naturally, this leads to economic challenges because we are redesigning equipment and retraining the workforce. The upfront costs for this new gear are higher. It requires a real initial investment to upgrade our infrastructure. But I want to leave you with the future opportunities because they are incredibly exciting. This transition is forcing the entire cooling industry to innovate. By redesigning this system, we are creating air conditioners and refrigerators that are highly energy efficient. In conclusion, yes, there are some upfront costs and technical hurdles, but transitioning to these green refrigerants is absolutely essential. We are growing a new green industry, creating sustainable jobs, and most importantly, making a massive dent in global warming. The long term payoff for our planet makes the effort completely worth it.
Finally, to conclude, refrigerant play an essential role in modern cooling and refrigeration system. However, some older refrigerant, particularly CFCs and HCFCs, are found to contribute significantly to ozone layer depletion. As we learn, the ozone layer is crucial because it protects life on Earth from harmful ultraviolet radiation. To address these issues, international agreements such as the Montreal Protocol and the Kigali Amendment were introduced to phase out environmentally harmful refrigerants and promote safer alternatives. Today, the industry is moving towards refrigeration with a lower ozone depletion potential and lower global warming potential, helping to create a more sustainable future. That's all from us. Thank you for your attention.